Okay, so in terms of trigonometry 2D and 3D, right, like I'm saying, right, we do need a bit of knowledge of in terms of knowing the sine rule, right? So remember, this says A over sine of angle A would be equal to B over sine of angle B, which would be equal to C over sine of angle C. Now essentially, right, what you need to master is the following. If you have a triangle, right, then you must know that an angle would be this, right? An angle is made up of two lines that meet at a point. So this is the angle formed by this line and that line. Now you must understand that the side that the angle is facing, this side, would be called the opposite side. Okay, would be called the opposite side. So when we say A and sine of angle A, we are talking about the sine of this angle. If this is theta here, we're talking about the sine of theta. And then if this is AB here, we're talking about saying sine theta over AB. You can write it as this, or you can even write the angles on top and then the lines at the bottom. Just make sure that you are consistent throughout, like this. Sine angle C over C. So you can write it like this, or you can write it like that. So hence here I'm saying this over that. Or so this you can also write it as AB over sine theta. Okay, the main important thing, right, is to understand that this is theta, the angle. Yeah, the main important thing is to know that the theta is the angle that is opposite the side. Okay, in all of the formulas that we're going to discuss in terms of sine rule, cosine rule, and the likes, let's understand that. Okay, right, and then let's see. And then now, the second formula we need to remind ourselves of is the cosine rule. Okay, remember that the cosine rule says that C squared is equals to A squared plus B squared minus 2AB cos of angle C. You must understand that this angle here, it's going to be this side will be the side that is opposite this angle. So that is why if I have a triangle like this, right, and then this is A, B, C, when I'm saying angle C, right, I'm talking about this angle, and then C would be this side that is opposite that angle. You understand me? That is the important thing. Then A and B will be the remaining sides. So this would be, A would be this one, B would be this one. So it will be AC and then BC. So you must remember that. I'm hoping you do. And then what else, right? That is the cosine rule. That's how we're gonna write it, and then we will see these things in application in just a second. And then the area rule, right? The area rule will be what you call, it's going to be area of a triangle is half AB sine theta. Okay, whereby AB are the sides that are adjacent to each other, and then theta is the angle in between. So A and B will be the ones that make up this angle. Okay, like this. That's when you can apply the area rule, right? And then we must have a bit of knowledge from SOHCAHTOA, right? Must have a bit of knowledge from SOHCAHTOA for us to successfully solve these problems. And then we must also have a bit of background knowledge from Euclidean geometry. Okay, from Euclidean geometry. You will see in the problems that I have for you today, right? Yeah, quite interesting problems, trust me. And then lastly, you must also have some bit of knowledge from measurements. Okay, measurements. So the question now is, how do I know what to use? How do I know which formula to use? I think that is the big question that we always ask ourselves. And then my answer is this. My simple answer is the following. Right. Make sure that you apply the cosine rule if you find yourself in a situation whereby the triangle is like this, and then you have all the sides given. So this side is given, this side is given, and that is given. Then please apply the cosine rule. As an example, maybe you have something like 5, 3, 1. You can apply the cosine rule here. You understand me? And then which other case do you apply? In which other case do you apply the cosine rule? Also apply the cosine rule if you happen to have V. Do you know the word V? There's this TikTok trend recently about Vivian. Don't know if you've heard about it. Such a beautiful song there. So the word V, right? The letter V. For me, it reminds me that this is when the cosine rule applies. You understand me? V. This is because if I'm given this side and then I'm given this side and I'm given an angle in between, then you can actually use the cosine rule. Okay, so if you have a side, and angle in between.
Sir,
yes, ma'am.
Is it similar to the area rule?
Perfect. Wherever you see the area rule is okay, you got it. Exactly similar, right? So where the cosine rule applies, the area rule also applies. Are we clear? You must know that whenever this cosine rule apply, then the area rule also apply. These two, they are brother and sister, right? They are brother and sister. They don't leave each other. Okay? And we only use the area rule if they mentioned the word area. If there is no word area, then forget about the area rule, right? So cosine rule, when we have Vivian, when you have V, right, the side, and an angle, and then or when you have all sides given. If you don't have any of these situations, then you just know that the sine rule applies. As simple as that, right? And then you must also know that the sine rule can apply. For the sine rule, you just need one angle and two sides, but the angle must not be an included one in most cases. But yeah, what is very important to know is where the cosine rule applies, and then if you don't have a situation like that, then you know that you can use the sine rule. Then the question is again, when do I use the sine and cosine rule on a triangle? How do I know that on this triangle I should use the cosine rule, or I must use the normal trig ratios? You must understand that this topic, it was called solutions to triangles back in grade 11. It was called solutions to what? To triangles. This is because the sine, cosine, and area rule, they apply to any triangle. You understand me? However, the ratios from SOHCAHTOA, they only apply on a right-angled what? Triangle. So usually on your diagram, if you see a right-angled triangle, just know that most probably you must use any of the ratios, sine, cos, or tan. You understand me? Any right-angled triangle you're going to see on the diagram, just know that SOHCAHTOA applies. But then if it's not a right-angled triangle, most probably you must use either the sine rule or the cosine rule. Right. And then the rest are, no, these are special cases like Euclidean geometry. This is just background knowledge you must know. So I hope that has maybe reminded you a bit, right? So let's see if we can actually apply whatever I've been saying here, right? Yeah, so let's see if we can apply that on our first question here. Hope you have your... Should I delete this? Okay, let me do this. In fact, instead of deleting them, sorry, let me just take this to the other side instead of deleting. Yeah, so this is what we have here, right? We are given that in this diagram we have points, right? B, D, and E, which lie in the same horizontal plane. Usually, if they are talking about a plane, they are going to talk about angles of elevation and depression. So when they say a horizontal plane, you must think of it as the ground. You understand me? When they say horizontal plane, they are saying on the ground. Right, so yeah, on the ground. So that is the ground there. Whatever you are seeing here on BED, that is like the ground where you will be standing. You understand me? Where you will be standing. And then any line that is going to be from the ground upwards, that is going to form an angle of elevation. You understand me? This would be called an angle of elevation. Why? Because it's like you are moving the ground upwards. Let's remember that a bed, I like using a bed for this illustration. Ooh, it's not always a very beautiful bed, right? But it's something that will be like this, right? A bed, when it's flying, right, its horizontal line is this one, its horizontal eyesight. But if it decides to look down, then if it looks down like this, it's going to form an angle of depression. You know, when you are depressed, you look down, eh? And then when it looks up, that will be the angle of what? Of elevation. Just like when an aeroplane is moving up, it's called an angle of elevation because it takes you know, an aeroplane. Oh, hey, yeah, one day, if maybe you have not been on an aeroplane before, right? One day you will be on an aeroplane by God's grace, and then you will see that if this is the aeroplane here, right? If this is the aeroplane here, and then it's about to fly, right? An aeroplane, when it takes off the ground, yes, it's going to move like this, and then it's going to go up like this. You see, it's gonna go up like that when it is elevating. When it's elevating. So because of that, that is why this is called an angle of elevation. Okay, so I hope that is clear. So if this is the ground, any line that will be from the ground up, it's going to be the angle of elevation. And then here, if this is a vertical wall, a line that will be, if I can draw if I can draw a horizontal line here that will be parallel to also the ground, then it's like I'll be moving the ground down like this. So this will be the angle of depression here. So the angle of elevation and depression are always equal because they are actually alternating angles, right? So that is a bit of revision from grade 10. Right, so it will tell you that this is an angle of elevation, this is also an angle of elevation, and then here, if you make this horizontal, remember the horizontal line must be parallel to the ground, right? This angle here will be the angle of depression. Okay, that will be the angle of depression. Here you will also have an angle of what? Of depression. So they must always be like that. Sometimes you don't even need that information, it's just there to complete the statements. But sometimes just used to describe these angles, to say they are just saying, instead of saying you have angle alpha. You just have alpha as AEB. They are not going to say that. They are going to say the angle of elevation from E is what? Is alpha. It's just a way to describe the angles. You understand me? It's not, in most cases, it's not like you're gonna do any calculations related to depression and elevation. In most cases, I didn't say every time, lest I be misquoted, right? Okay, so yeah, it's just a way to describe the angles, right? So what are they saying? They're saying here, the first thing is that we do see that there is 90 minus that and then alpha. Determine the length of BE, right? Meaning from B to E in terms of H and alpha. When you are solving these problems, make sure that you always try to locate the triangle in which you can work in by using the information in the question itself, because they're talking about height, H and alpha. You can see that they are in this triangle ABE. And what type, the second question you ask yourself, what type of triangle is triangle ABE? It's a right angle triangle. Then you know that in here I'm going to use SOHCAHTOA. What type of triangle is BED? Is it a right angle triangle? No, it's an obtuse angle. Then in here you're going to use the rules, right? Let me just write the rules, either cosine or sine. In here it's a right angle triangle, so you're gonna use SOHCAHTOA. You see, if you can do this to any diagram, you'll find that it's very, very easy. Just identify the right angle triangles, identify those that are not. Okay, so then from there we can try to solve that and see if we can get what they are looking for there. So they want BE, right? You ask yourself, the angle that is given is alpha. What is the relationship between the angle and the given side? You can see that you cannot say that BE is opposite alpha, guys. No. You can see it's adjacent, because the one that is opposite the right angle, let's remember that it will always be the hypotenuse. This one here would always be the what? The hypotenuse. Okay, so we can definitely say BE is adjacent to alpha. What about AB, which has H from the question? AB, you can see that it is what? It is opposite. You understand me? So these two things should give you a ratio. When you write SOHCAHTOA down, when you write SOHCAHTOA, and then you tick in everything that is adjacent, then you tick everything that is opposite. The one with two ticks, the ratio with two ticks is the one you're gonna use. So in that case, it means that for 9.7.1, we are going to use tan. So we're gonna say tan alpha is equal to opposite, right? The opposite over adjacent. The opposite is what? Is AB. Adjacent is what? Is BE, right? Meaning that we're saying tan alpha or tan AEB, right? I was supposed to write it as tan AEB first before I can substitute. Ne? Let's write it like that. Tan angle AEB. Remember, AEB is alpha, right? It's gonna be equal to the opposite, which is AB, over the adjacent, which is BE. So we're saying that tan alpha is equal to 2H over BE. I don't have BE, but they want BE, right? When they say determine the length of BE, BE must be the subject of the formula. So these, you know from proportionality theorem that you are able to switch these two. So you are able to say BE is equals to 2H over tan alpha. If you feel like this will be a problem, then you can cross multiply. You can say 2H times 1 equals to BE tan alpha. Then you divide by tan alpha both sides. Then you'll be left with BE. Okay, so you have gotten your 2 marks there. 7.2. Show that ED is H tan alpha. Which one is ED? Now, one thing also that you must always do, label the information that you get on the diagram so that you always be so that you won't get stuck. If you don't label, trust me, you might get stuck. So now what do we want? We want ED, right? Look at ED. It's in this triangle whereby we need the rules, but also it is in triangle EDC, which is a right angle triangle. So we are looking for ED. And then there is H there, meaning that we can use CD again. So it means in this right angle triangle, I have to then say ED is adjacent, CD is opposite, still it's tan. Okay, so you're gonna say tan 90 degrees minus alpha is equal to H, which is the opposite, over ED. Then to get ED, you simply say it will be H over tan 90 minus alpha. Right. A tan 90 minus tan 90 minus alpha. Is it tan? Wait. Opposite over adjacent. Yeah, it's tan. So how do we deal with tan 90 minus alpha, guys? Yes?
Sir, don't we convert it to sine 90 minus alpha over cos 90 minus alpha?
Yeah, exactly. So we do have to write this as sine 90 minus alpha over cos 90 minus alpha. Perfect. Of which, if we do that, you are going to have yourself cos alpha over what? Over sine alpha, because 90 minus, remember, it has to change. So sine change to cos, cos change to sine. Then this one, you can now say, since this is a denominator, you know, I like to say, if the fraction is the denominator is a fraction, then you can say this is H cos alpha multiplied by the denominator at the bottom, right? So therefore, sine over cos is simply tan alpha. Good stuff. So that will be ED there. Get your 2 marks. So it's always important to write it. Now we have ED as H tan alpha. Perfect. Then then now the real things they start. Show that, prove that BD is equal to that. Let me do this. Okay, so now let's actually solve what? 7.3. 7.3. Remember I said you must label. When you are labeling those things, whether you know the value of tan or what, it's very important to label because it serves as one of the given sides. For example, now they want you to find BD, right? They want you to find BD. And when you check in this triangle BED, don't you have Vivian? Don't you have V? You have this side here, BE, you have this side here, ED, you have 120 degrees. Then it tells you that I can use what? Cosine rule. I was telling my grade 11 students today that actually this thing here, you can do it like this. If you want to remember that Vivian is cosine rule, that V there, you can turn it like this. It will you will see and I must use cosine. I must use cosine rule. Okay, so now to get that BD right, you will say, remember you have to say the one that is opposite, meaning the one that is here, that is the one that you square, right? So remember that this one you square it, these ones you square them, and then you add them. So you're going to say BD squared, meaning this one squared, the one opposite the angle, and then you say is equal to the other two squared added together. So BE squared plus what? ED squared, right? BE squared plus ED squared, and then you say minus 2, right? Minus 2, because it's two sides given, minus 2. Then those two sides you multiply them, meaning you say BE multiplied by ED, and then you say cosine of angle what? The angle opposite BD. That angle is 120, which is angle BED. Don't call it angle E. I think from Euclidean you remember that angle E is the whole thing here, so it's BED. BED. Perfect. So let's start working with the other ones first. BE, we already have it as what? 2h over tan theta. 2h over tan alpha. And then ED, we have it as what? As h tan alpha squared. And then 2, then you say 2h tan alpha, and then multiplied by h tan alpha cos of 120 degrees, right? Now when you simplify this, you should get 4h squared all over tan squared alpha plus h squared tan squared alpha. And then here I think tan and tan must eat each other, so that you are left with what there? You are left with minus 4h, right? Minus 4h squared, right? Because this is h here. And then cos 120. Remember, this now requires information or knowledge we learned in reduction formulas, right? Remember, if you don't forgot, Nyana, you can always go back to those videos we sent, right, or we posted. So now 120, remember, it's in this quadrant, right? 120 is in quadrant 2, so that quadrant you're going to say cos 180 degrees minus a certain angle to get 120. You have to subtract 60, right? So you have this, and then you continue solving. You have 4h squared all over tan squared alpha, and then plus h squared tan squared alpha, and then minus 4h squared. Then you're gonna have cos 60, isn't it? Cos 60 degrees. Because of, okay, let's write it. 4h squared.
Sir?
Yeah?
Sir, write cos 180 minus 60 is in the second quadrant. So aren't you supposed to say it's negative cos 60?
Oh, yes. Second quadrant. Oh, thank you so much. Yeah, second quadrant. So we must take a negative. We must say it's negative cos 60, right? Which is going to make it a positive. Okay. Yeah, very nice. That's true. And then we have h squared tan squared alpha, and then 4h squared cos 60, using the 1, 1, 2 triangle and the 1, 2, 3 triangle. This one is the 1, 2, 3 triangle, right? The 1, 2, 3 triangle, and 60 is around here. So cos would be half. So this is times by half, right? And then what can we do? We can combine these two first. We can put this as all over 1. Then remember, how do we combine fractions? Now this requires knowledge from identities, remember. So we say the bottom parts, we multiply them together. You have tan squared alpha. Then you say 1 times this, it's going to be 4h squared. And then you say tan squared alpha times by this. Then you're gonna get h squared tan 4th power alpha. Yeah, 4th power alpha. And then here you're gonna have what? 2h squared. Right, so this is also what? This is also over 1. So we're going to now combine these two fractions, right? You don't combine 3 fractions at once. Try to combine them 2 by 2. So when you have to combine this one, what are we going to get, right? It's just algebra here. So we're gonna have this times that is going to be tan squared alpha. Then we say this multiplied by all of these, right? It's going to be 4h squared plus h squared tan 4th power alpha. And then we say this multiplied by that, you're gonna get 2h squared tan squared alpha. Okay, so do not forget that all of this is equal to BD squared. Yeah, then what can we maybe do there? We can take maybe a common factor, right? So I'm hoping that we are together here. I'm going to try and, you know what, let me make this small so that we can continue working. So did I write BB or BD? Hey, it's BD, right? Right, so here we can take out a common factor. We can see that the common factor there is what? Usually what I do is that I'll write this as it is. I write it as it is, and then I write this as it is. Right, then I say which one is common there. You can see that 4 is not common, but we can say 2 is common. So you can divide all of this by 2, and then what other thing is common? H squared is also common. Is tan squared is not really common because here we don't have tan at all. So this is the only common factor. So you're gonna divide by it throughout. Then you multiply by it outside, right? That is how I take a common. I factorize using highest common factor. And then you have tan squared alpha, and then when you simplify it, what do we get? Yeah.
So isn't it only h squared that is common?
It's 2h squared.
So what we're saying 2 is common, yet we only have 2 in the first, in 4, and then the second one we just have h squared tan 4 alpha.
There's no 2 here. Okay. Your argument is correct. Okay, so we can remove the 2 then. Is that okay? We leave just h squared. Ne? Right. So in that case, if we do that, then we should have here they divide, you're left with what? 4. Here you divide, you're left with tan 4th alpha, and then here they divide, you're left with 2 tan squared alpha. Then you divide all of that by what? Tan squared alpha. Perfect. And then we can find the root, right? So that therefore we say BD would be, remember Kerry, if you have the root of A over B, this is the same as the root of A over the root of B. So it's the root of the numerator and the root of the denominator. But let's remember, right? Let's remember
Excuse
that
me,
here
sir.
outside we have A squared. Yes?
Excuse me, sir. Okay. I put it.
We have it, ne? Okay. Nice. So when we say the square root of the top part, right? Remember it's going to be the square root of this part and then the square root of this part. So the square root of h squared is simply h, and then this part we can leave it like this to say 4 plus tan fourth alpha plus 2 tan squared alpha, all divided by tan alpha. Okay, then you're getting, truly speaking, good people, you see, the moment you substituted this, you already had your answer. To be honest with you, the moment you substituted that, you already had your answer. What was just needed is to simplify it until it looks exactly the same as what they wanted you to do there, right? But the concept is that when you have right angle triangles, try to apply SOHCAHTOA in them. Then when you have a triangle that is not a right angle triangle, then use either the sine or the cosine rule, depending on the information you have. Do you have V? Do you have all sides given? If you don't have those, most probably you need to use the sine rule. Right, quite easy. We good. I hope we're okay. If you have any question, you can ask. Right, remember, I have you guys to ensure that you assist me. If we make errors, hey, I'm with you. We made errors. But yeah, I trust you guys. I know we can never go wrong. All right, so here's what we have in the next one. AD is a vertical structure. B, C, and D are 3 points in the same horizontal plane. The angle of elevation of A from C is theta. You see, they will say it so that they can describe this angle, right? And then BC is K, right? And then AB is 2BC. Aha. So AB, this one, is what? Is 2BC. Good people, labeling is very, very key, right? You label it 2BC. Wait, if it's 2BC, this actually means it's 2K, because BC is K, right? So labeling, very crucial. And then ABC is 2 theta, right? ABC, which is this one for this triangle here. For this triangle. For this triangle here, we have what? We have 2 theta. Remember, there is a horizontal. You must think, your brain must show you a 3D version of this, eh? So this is what we have. You must understand that AB is a line on triangle ABC. It's also a line on triangle ABD, ne? You must also take note of that. So prove that AC is equal to that, right? Prove that AC is equal to that. That is okay. In triangle ABC, it's not a right angle triangle, right? But what are the sides given? Which rule are we going to apply there, guys?
Sir?
Yes, ma'am.
So I think it's a sine rule, a cosine rule.
Why cosine?
Because we are given a side and a side and an angle in between.
Right.
Then we have to find an opposite side.
It's V, ne?
Yes.
Remember, I like calling cos a lady, so Vivian really goes along with the lady. Yeah, so indeed, this is the side, this is the side, and then there's an angle, so we can use the cosine rule. So for 7.1, we would simply say that AC squared, right, which is this side squared, would be equal to the other two sides squared, meaning AB squared plus what? BC squared minus 2, right? And then AB times BC, and then cos of angle what? Of CA or ABC. Cos of angle ABC. Right, so remember, this side is the one that is opposite this angle. Okay, let me write it here. Right. So we have AC squared will be equal to AB is given as 2k all squared, and then BC is given as k all squared, and then we have 2 into 2k times k, and then cos of 2 theta. Right, so this means that we're gonna have 4k squared plus k squared, and then minus 4k squared cos 2 theta. Right. So now this is whereby now you go to the question, and then the question is having a bit of sign there. Then it tells you that for sure this cos 2 theta, since it's a double angle, you need to change it to what? To the one with sign. Right. 4k squared plus k squared minus 4k squared into k cos 2 theta will be 1 minus 2 sine what? Squared theta. Right, then you can say 4k squared plus k squared minus 4k squared when you multiply this and that, right? And then this and this should give you 8k squared sine squared theta. Right, so now what will happen? This must eat that, because now those ones, they cancel each other, they use due to subtraction, right? And then you have k squared here and k squared there. That is your common factor. So I'm gonna rewrite it like that: 8k squared sine theta, and say the k squared is common. So I'm gonna divide by k squared, divide by k squared, and then do not forget to multiply by it. Then now you're gonna have k squared into 1 plus 8 sine squared theta, because this and that cancel, this and that cancel. But remember, you have AC squared, right? Then you can take the root both sides, so that you have AC. Remember, the square root of k squared will be k, and then you'll be left with the square root of what is inside, like that. Right. Oh, squared. Oh, madam. Squared. Yeah, then you should be okay. Then calculate the value of AC rounded off to the nearest meter if k is that is 139.5 meters and theta is that. If it happened that, good people, you were not able to prove 7.1, don't be afraid to take this whole thing and just use it on 7.2, right? So for 7.2, to get AC, we'll simply say 139.5 meters, the root of 1 plus 8 sine squared what? 42 degrees. Then you're gonna put that in your calculator. The way to put it in your calculator, let's remember that you're gonna say 139.5 root of 1 plus 8. Then you say, you put a bracket, you say sine 42 degrees, and then you close your bracket. So you're gonna have a bracket here again, then you say squared, so that you get your answer. So how much do you get as AC?
298.60.
Oh, nice. So that will be 298 meters. All right. Right. So yeah, that is nice. Any question? Remember, we used cosine rule. That is the name, because the name of our lady there is Vivian. V, right? If you have V, side angle, then you know you can use cos, right? That is it. Let's look at this one here, right? Don't worry, I have a beautiful homework for you guys, so don't mind me if I'm solving this. Yeah, I have very nice homework for you guys. Okay, so this is what we have, because I want to go through to say what to do, right? Because we get stuck on these questions and they're quite easy. So here we are, ABC is in the horizontal plane. P is a point vertically above A. The angle of elevation of B to P is alpha. You see, They will say it so that they can describe this angle. Then ACB is beta, and then you have this as theta, and then BC is 20. Good. Write AP in terms of AB and alpha. Where is AP? This is AP here. You want to write AP in terms of what? AB, in terms of AB and alpha. How? And you are working in a right angle triangle. What do we use? You know, SOHCAHTOA. In a right angle triangle, we use SOHCAHTOA. So AP, you can see that it's opposite, right? The alpha, and then AB is adjacent. That is your tan, isn't it? So that's why write it like this. You see the way I'm writing it inside of the triangle? Write it so that you can easily remember that if you have opposite and adjacent, it's going to be tan. Right, and then now for 7.1, we need to write AP in terms of that. So we can say tan alpha will be equal to the opposite, which is AP, over the adjacent, which is AB. So therefore AP will be, you multiply by AB both sides, you're gonna have AB tan alpha as your AP, and you get your nice 2 marks there. Then you label it. Don't forget, you label it. So AB is now going to be AP tan alpha. Right, we label it. Then after that, they ask you to say, now prove that AP is equal to this. I prove that AP is equal to that. Already, as what we have as AP, we have AP as AB what? Tan alpha. You write it and say, since I have this and they want AP to be equal to this, I have to change this so that it goes to that. You understand me? So that it goes to that. The only way I can do it is if I find the missing side, AB. You understand me? If I can find AB, I can simplify AP to be like what they want. So how do I get AB? This is AB here, right? That is AB there. How will I get AB? Which rule must I use? Cosine rule, sine rule. They didn't talk about area, so I'm only gonna choose between these two. Yes, ma'am.
So you confused it because you wrote AP tan alpha or adjacent AB instead of writing it to AP.
I said tan alpha is opposite, it is AP over AB, right? Oh.
Same. Like actually AP.
Okay. Okay. Yes. So all right. I get you. Thank you. So it means I labeled on the wrong one. Okay. So this one is the one that is AB tan alpha. Do we agree? Right. That is AB tan alpha. Okay. AP is AB tan alpha. Oh yeah, not AB. Sorry. So now we need to find AB, right? And then yes, in this triangle we use SOHCAHTOA. But then how are we going to find AB? AB is also in this triangle, which is not a right angled triangle. Now the question is, which rule do you use in there? And why? Between the sine and the cosine.
Would you use sine?
Sine rule, sine. It smells nice, but then what inspired your choice?
The theta and the beta, because there's angles and there's a side.
These angles and a side. Okay. Okay, that is okay, right? That is very good. That is very, very good. But another way to think of it is that you ask yourself this checklist, this small checklist. Do I have all of the sides given? I have only one side given. Wrong. Do I have a side, and then an angle in between? No. Then if this checklist says no and no, then therefore I'm gonna use the sign rule, so that you don't have to cram that if I have one side, two angles, what no. Just ensure that you use this checklist. If this fails, right, if it's not there, then you can use sign rule. That's how it will be. But that's a very good choice there, right? So I will say AB, right, over sine of the angle that is opposite AB. That angle is what? Is sine beta. You understand me? Sine beta. And then usually it's then beneficial now to talk about what? To talk about the side that you are given, which is BC. So remember, you need two fractions per se, right? So now it's beneficial to talk about BC, right? BC over sine of angle what? BAC. Okay, because I know the length of BC. I'm avoiding to use AC because I don't know the length of AC, right? The two lengths I chose is number one, the one I want. Number two is the one that is given. That is what is inspiring my choice there, right? So now AB over, now let's understand that is here it is sine B. BC is given as 20, but what is sine of BAC? Let's understand that BAC, we can get it because we have two, where for sine rule, when it applies, you will always have two angles. You understand me? So because of that, you can get the third angle here. Remember using what? Sum of angles in a triangle, right? So this angle here should be what? 180 degrees. Should be 180 degrees minus the two angles theta plus beta. You understand me? Theta plus beta, because sum of angles in a triangle is 180. And the way to, if you want to see whether that is really true, you can say BAC plus theta plus beta must give you 180 degrees. You give a reason, sum of angles in a triangle. Yeah, try to write this, and then after that substitute BAC as this, né? Because now BAC will be 180 minus the 2. They are going to go to the other side. Okay, so now we can solve for AB. We can say therefore AB is equal to 20. Then you multiply by sine beta both sides, so that you have 20 sine beta, all divided by sine 180 minus this. It's in the second quadrant, so you're going to have sine of those two angles like this. That's AB. Then now that you have AB, you must be rejoicing, because you can now substitute it there to get AP. So we can now say AP will be equal to 20 sine beta all over sine theta plus what? Beta times tan what? Tan alpha. Oh, it actually simplifies to this, because now you can just write it as 20 sine beta tan alpha, right, all over sine theta plus beta. Usually that's how we do it. not difficult. 7.3, I believe you can easily get that one, guys, right? So AP, in terms of alpha and beta in its simplest form, you're given AB is equal to AC. They say given that AB is equal to AC, right, meaning that AB is equals to AC. So this is equal to AC. Okay, meaning this line here, AB is equal to AC. Determine AP in terms of alpha and beta in its simplest form. Determine AP in terms of alpha and beta in its simplest form. So now we're looking for AP, right, in its simplest form. You are given that AB is equal to AC. And let's remember that all of this is what? All of this is AB, right? All of that is AB. So we are now told that it is equal to AC, of which AC, we don't have, we don't know its length, right? We don't know its length, but so let's understand that since AB is equal to AC, means this ratio here, oh, I hope it's, let me write it here. So it means AB over sine beta will be equal to AC over sine theta. And if this and that are equal, it should also mean that this and that, they are equal, right? So it then implies that sine beta is equal to sine theta. But is that going to be true though? I'm trying to think of this situation, trying to think of this scenario here. To say maybe I'm making a premature conclusion, but already we know that the fraction there, those fractions are equal. So those fractions, they can only be equal if the bottom parts are also equal. Yeah, that's the only way that it will make sense, because from the definition of the sine rule, we are saying that the side over the sine of the angle will be equal to the side. You see, we are saying that they are equal, so it means if this and that they are equal, this and this should also be equal to make the sine rule true. You understand me? I hope that you are with me there, right? So it tells you that the sine,
yeah, I don't understand.
Yeah.
Okay, is
The way I'm looking at it, it says AC equals to AP, right? Which means that we'll take it back to the isosceles triangles, whereby it says opposite angles equal sides, right? But we will use converse of that. We will say opposite sides equal angles. Oh yeah. Yes, but something like that, man. Yeah.
No, you are right, sir. Theta is actually equal to beta due to it being angles opposite equal sides. Right. Yes, that's true, sir. Yeah, you see, Mr. Lema supports me, because that will mean if I put sine here and then I put sine there, sine theta and sine beta should be equal. Is that not true, sir?
Yes, man. Yeah.
Right. Ma'am, do you understand now?
Yes, sir.
Good stuff, good. Yeah, you see, I had not looked at the triangle, right? But I looked at it from the definition of the sine rule itself, right? To say there's no way that these fractions can be equal when the numerators are the same, but the denominators are different. There's no way. So it means these two, they must be also what? Equal. And then you can see it from the fact that it's an isosceles, right? So because of this, right, this can actually open many doors for us. Why? We can now simplify this part. sine theta plus beta, right? Then I'm going to try and do it on the next side, because now we know that sine beta and sine theta are equal, right? Right, let's see. Oh, and again, we said tan alpha. Oh, alpha and beta. Oh yeah, alpha is there. Yeah, I was now worried. Okay, so let's take it this side. Oh, let's remove here. Yeah, perfect. This is what we have here. So now we can simplify this using the compound angles, because this is a compound angle here. So you can say 20 sine beta, and then down here you say sine, wait, now you can say sine, remember theta and beta are equal, right? So now what can we say? I want to express it in terms of beta. I can actually write it as what? As 2 beta, right? And then say tan alpha. You understand me? Then after that I can say 20 sine beta all over 2 sine beta cos beta, right? Then here we can cancel, and then 20 divided by 2 is what? Is 10. So you're gonna have yourself 10 tan alpha over cos beta. Alright, this is the simplest form we can have. That's the simplest form we can have. Okay, because it is alpha and beta. So thank you so much for that, Mr. Liema. Very, very good observation. It does solve the puzzle. Okay. Good. Was that the last one? Let's see. Oh, I had this one again. Right. So do not expect that you will always get those old type of questions. Nah. Times have changed, good people. You can also get something like this as part of 2D trigonometry application. Right. So here it's like a combination of Euclidean and 3D, right? Or 2D or 3D, yeah. 2D is 2D, this one. So PS is a tangent. We are told that this is a tangent. We stop net da because the circle is because we already see that PR is a chord, right? PR is a chord. So the moment they said there is a tangent and then there is a chord, we know that the angle between the tangent and the chord should be equal to the angle formed or subtended by the chord on the circumference, meaning this should also be what? Theta. Very, very important to apply your rules there. Right. And then we are told that PR is close to RS. So what does that mean, Mr. Liema? You remember, since this is theta here, it definitely means here we should also have what? Theta, because those are the sides opposite equal angles, right? Then they want that. So whatever we have written there, let's tell the examiner, right, that we actually identified that SPR is equal to angle Q. Our reason being what? Tan chord theorem, right? Tan chord theorem. And then you have so therefore that will mean that SPR should be equal to theta. Then SPR should be equal to to angle S, right? Why? Angles opposite equal sides, because it was given that PR is RS. It was given, so those will be equal. So that means angle S should also be what? Theta. Then what will be angle SRP? So SRP will be 180 degrees minus 2 theta due to the sum of angles in a triangle. So this one here will be 180 minus 2 theta here. Perfect. Yeah, so what do they want, kahle kahle? They want PS, right? Where is PS? Here it is. Good people, looking at SRP, what rule are we going to use? Because it's not a right angle triangle. Perfect. Yes, Vivian, for sure. Because we have a side, and angle in the middle there, or in between. Right. So when we use the cosine rule, we can say we have PS squared being equal to, remember, right? RS squared plus RP, which is this one, squared, minus RS times RP. 2, very important to put the 2 there, and then cos of the angle opposite to PS, right, which should be SRP. Now when you then substitute there, RS is x, so you have x squared plus x squared minus 2 into x times x, and then you have cos of 180 degrees minus 2 theta, right? And then therefore you will have 2x squared, and then you have 2x squared again, and then cos 180 minus, it's it's in the second quadrant, whereby cos is negative, so we're gonna say negative cos 2 theta. Then in that case, that will allow us to have what? 2x squared minus, the minus times the minus is plus, so you have plus 2x squared cos 2 theta. Then which one is common there? What is common there? I believe we can see that 2 is common in both, x squared is common in both, so we can say 2x squared, 2x squared. Don't forget to multiply by it, right? Then what are you gonna have? You have 2x squared into 1 plus cos 2 theta. Then you have PS squared. Okay, root both sides. You are going to have PS being equal to x into 2, right? Because the root of 2 is just the root of 2. And then in here you have 1 plus cos 2 theta. The one that has a square root, you just take it out in simple terms. Then now that we have this, it doesn't look like that, right? So it tells us that we still need to work even harder. So we say PS is equal to x. Luckily, because you have cos 2 theta, you know you can change it to the one with cos, because you have cos here, right? So you will say 2 into 1. Actually, let's multiply this inside. 2 times 1 is 2, and then you have 2 cos 2 theta. So that will mean that you have x 2 plus 2 into 2 cos squared theta minus 1, isn't it? And then you can substitute. This is gonna take, okay, so this is gonna be 4 cos squared theta, and then what? Minus 2, which will be x into 2 minus 2 is 0, right? This and that cancel. You are left with 4 cos squared theta as your PS, which means you'll have x, the root of 4 is 2, right? Cos theta, which means you simply have 2x cos theta. Shoo, aye. But okay, so but good people, like I said to you, I'm gonna repeat it again.
Sir,
Yes.
can you please explain from the yellow part where there is negative cos 2 theta, starting from there?
Wait, here to here.
Yeah.
Your angle is 2 theta, right? And then you have 180 minus. So since you are dealing with cos, and you are dealing, and this is in the second quadrant. In the second quadrant, remember that cos is negative. So you should have negative of that angle, negative cos of that angle. That's why you have negative cos 2 theta. Then now because of this negative and that negative, they multiply each other, then you have a plus. Are we together there? Or a question?
Yes, sir. And then?
Then now you see that there's a common factor. There's 2x squared. There's another 2x squared. You can take that 2x squared out by doing what? You divide by 8, then you multiply by 8. That will mean that 2x squared divided by 2x squared, it should be 1. And then this also divided by that should be what? They just cancel each other. So you're left with cos 2 theta. Then here, right? Here, we are using this law that we learned in grade 11. That you remember the root of AB is equal to the root of A times the root of B. So if I have the root of 2x squared, 1 plus cos 2 theta, what I do is that I take this as if it's A, or I can take this, so this will be the root of 2 times the root of x squared times the root of this, 1 plus cos 2 theta. So here is still the root of 2, x squared is x, right? And then here you have the root of 1 plus cos 2 theta. Then you know that also this goes in reverse to say if I have square root of something times square root of something, it's just square root of that something times that, meaning whatever is inside, right? So same thing here, square root of 2 times the square root of this, it's going to be the square root of 2 into that. You understand me? So that is why we end up here. Right, that's why we end up here. Then I'm multiplying 2 inside now. 2 times 1 is 2. 2 times that is 2 cos 2 theta. Then I change this cos 2 theta to a double angle that has cos, because in the question in itself you have cos there. You are always driven by what you have on the question. So I change it to 2 cos squared theta minus 1. Then I distribute this inside. I get this, these two cancel, and then still using the law again, the root of 4 cos squared theta will be the root of 4 times the root of cos squared theta. The root of 4 is 2. The root of cos squared theta is cos theta. So that's why we're going to have this and then that. Is it understandable, ma'am?
Clear.
Very sure.
Yes, sir.
Okay. Alright, so that is it, guys, right? That is how we deal with these solutions to triangles. Please just make sure that you identify the triangle. If it's a right angle triangle, you know you're going to apply SOHCAHTOA. But if it's not, you're going to apply the sine or the cosine rule. How do you know that I must apply the sine rule or the cosine rule? You follow this checklist to say, are you given all the sides? If you are not given all the sides, and then you also don't have Vivian, meaning you don't have angle, side, and angle in between. If these two have failed, you will use the sine rule. But if one of them agrees, you use the cosine rule. You understand me? Then the rest is simplification. Your problem here, it ended long ago. The moment you found this, like you found that you must use this rule, this cosine rule, you finished with the problem. The rest was just to simplify. You understand me? So that is how these things work. And then if there is another concept like Euclid, remember all the properties or the theorems in Euclid to help you solve your problem. Right. So your homework will be this, and then I'm going to send it in the group there. beautiful question here. Very, very beautiful question. I'm very interested in what are you going to get there. Already I see that there is a bit of a mistake here. They are saying 4, 5 and 6, but you have 4, 5 and 3. No, this is a mistake, ne? It should be 6 here. Okay, it should be 6 here. Right. Yeah. Then we want to prove that it's going to be equal to this, ne? So I'll send it in the group that you can give it a try. Otherwise, that is what we have for you for today, guys.